Before you graph tan, you've got to remember two important facts about how to graph tan and fill out the parent table. One is that tan angles go from -2 pi, pi over 2, to positive pi over 2. For cotan, you're going to be using the angles that go from 0 to pi. And along the way, you're going to hit pi over 4, 3 pi over 4. But the 5 values of tan for your standard parent table are, and you're going to, this is the only parent table where you use negative angles, negative pi over 2, negative pi over 4, 0, pi over 4, and then back to, well, not back to, but up to positive pi over 2. Okay. And also, what you should have in your head is the shape of this graph. Y equals tan x are these kind of curves. They notice how they curve up. So the three values on your parent table are going to coincide with right here, which is pi over 4, and that'll hit -1. At 0, your y will be 1, and at positive pi over 4, you'll be at positive 1. And you will have asymptotes right here, right here. And the x of this is negative pi over 2, and the x of this is positive pi over 2. So back to our parent table. We got our x's here, y equals just tan x in this case. And the x's will just stay the same. And the only difference is we'll have 2y. So all these values will double. So at negative pi over 2, it's undefined. You need to know that. Right here, tan is undefined. At negative pi over 4, value is -1. At 0, it's 0. Pi over 4, value is 1. And then when you're up at pi over 2 is undefined. Okay, so when you take 2 times something undefined, it's still undefined. That becomes -2. That stays 0. That's 2. This stays undefined. Okay, so in this case, you're asked to graph 2 cycles of this function. And so let's put down our x values. Negative pi over 2, pi over 4, 0, pi over 4, pi over 2. But we keep going. We keep going by quarter steps. So if we call that 2 pi over 4, which is the same as pi over 2, we can say this is 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, and 6 pi over 4. That just makes it easy to kind of know these steps. But you know that's pi. And this is 3 pi over 2. Okay, but let's graph one cycle. At negative pi over 2, what did we have here? Oh, that's where our asymptote is. And our other asymptote is right here. So checking the same width, this asymptote will be there. Okay, and that does conform with this picture. You notice how unless it's been shifted, tan of x passes through the origin. So there are 3 points that we're going to map. Oops. And they are at -1, 0, +1, and it went this one, and then this one. And we can repeat that pattern for 3π/4, pi, 5π/4. Oh, goodness. There's been, y's are not the same. It's stretched. So you know what I'm going to do? I'm going to relabel this. This is -2, and that's +2. So the only difference when you're asked to graph cotan is, again, your values will go from 0 to pi, stopping at π/4, π/2, 3π/4, and then pi. So that's just a fact that you'll have to memorize. The other that that you want to keep in mind is that the shape, by contrast, the 3 middle points between each asymptote has a falling kind of pattern. And then the asymptote doesn't start back here at -π/2. It starts at 0 and ends at pi. So that's the difference with cotan.